Hey everyone, welcome to the stream. Just gonna stop my music. All right, so so I've been working actually on Vectrexy here on and off since last stream, and I got quite a lot of stuff, done since last stream. So I thought I'd start off by just kind of going through most of those changes, at least the major ones. So let's see here. See if I can figure out 12th. Move audio ImGui. Oh yeah, so stuff like this. Yeah, this is probably where I started. So last stream or last couple of streams, we worked on basically digital audio samples or direct audio samples being sent from the CPU. And I've actually made some nice work on that, and I've actually improved the quality of that. So that's pretty cool. I'm gonna be sharing that soon enough. But yeah, so this change here, let me see here, move audio ImGui debug stuff to regular debug. I had started adding this second audio debug window, but I decided to drop that and decided to group everything under the main debug window, just because it's simpler. And what I decided to do is kind of like a little cute little hack, if you will, where I use let's see here. I use checkboxes and I kind of group a whole bunch of stuff with these checkboxes. So I'll actually show that. I wonder if I can show it right now. I think it's easier to see than to talk about it. So let's say I pause this for a sec and I show the debug window. So here's the debug window, and you see now I have all these checkboxes for each section of stuff because it's starting to get really, really big, So having it all shown at once was kind of difficult to navigate. And also, some of these are actually expensive, and now they're guarded by the fact whether or not we want to see them. So for example, if I click GL render, we'll get all the GL render options, STL audio driver here, the PSG ones here, and the screen ones here. So this will allow me to basically keep my focus, So if I just want to look at PSG stuff, which is what I'm going to be doing tonight, I can just enable that, and we should be good to go. So that's that change. So this is one I had actually spoken about on stream. Basically, the way I had modeled everything is that the input to the SDL audio driver was expecting float values in 0 to 1. And as it turns out, actually the driver really wants, if I'm going to be sending floating point values, it wants it in -1 to 1. And not just that, it turns out that it's actually easier to work in the range of -1 to 1 because then 0 becomes your center line. And so I decided to go ahead and make the change to my code base so that from the PSG, when it's basically the target samples that we produce are in the range -1 to 1. So things where previously I was returning 0.5, I now return 0. This conversion I was doing before to scale the volume around the 0.5 mark now is unnecessary. I can just compute my sample. Well, here actually what I do is my hardware is still returning integer values in 0 to 1, so that's fine. But then I take that and I scale it into -1 to 1 right here. Final sample. Sample times 2 minus 1, and then I can just scale by volume. So that's scaling around the center, which is 0, and then I return. So it simplifies this code. I think it's a lot easier to understand. I had to change a couple of my remapping functions. They've, for example, for the float, it just is as simple as returning the value because it's in the correct range. Nothing really interesting there. Let me see here. Oh yeah, I fixed a little reset thing. Nothing major. I think there in here. Yeah, actually I didn't. Yeah, this change here is a little bit more than what I'm saying in my change. So Hey, local root. No, I just started, actually. I usually start my stream by going over some of the stuff I've worked on since the last stream on my own time, so that's sort of what I'm doing right now. But I'll be digging into code soon enough. Yeah, there's also kind of an important change, and I didn't really document it correctly here, but so yeah, part of it is the 0 to 1 being remapped to -1 to 1. I no longer need to do this remapping here for the direct samples. But down here, let me see here. Yeah, the important change that I realized, oh great, well, it's glad to have you here, local root. The important change here is that I had this function. Originally it was called just update integrators, and then I had added and PSG to it. I actually went back to calling it update integrators and added a new function, update PSG. And the reason for that is this function, update integrators, needs to be called in two places. It gets called when we write to port B and to port A. But see, the port A thing here, is it here? Let me see. Port A is connected directly to the DAC, which in turn is connected to both MUX. Yeah, so this here is kind of like, I had read this in the documentation, specifically for integrators values alone. When we write to the data to port A, which is the DAC register, if the data direction is right, we need to also update integrator values at that moment. But we don't want to be updating the PSG values here, only when we write to port B, which is actually the one that is supposed to actually get these values set, because those values come from port B. We can see it here, like an update PSG, we have this port B reads here, and we also have a write of what was in port A. So what was happening was that actually I had cases where some games will mix the sending of direct samples and rendering at the same time. And when that happens, they end up writing to port A for rendering purposes. And my previous code would end up kind of crushing the PSG's port A value through here. So it was wrong. And so I split them back up and I just make one call to update PSG. And this actually fixed quite a few issues I was having with direct samples. And I'll be demoing that soon enough. Let me just see what else I did. Yeah, this is actually related to what I was saying. Let me see here. Anything worth really going over? I think the crux of this change is that if you were paying attention last stream, one of the things I did, and I hated it when I did it, and it kind of bit me in the ass, is that what I was doing for direct samples is I was caching the last sample. That was the last direct sample. Every time we would write one, I would just kind of remember it. And then when it was time, like, let's say at the frequency of 44,100 cycles, we would want to, produce a sample for sound. I would say, okay, well, what was that last direct sample? I'll just, use it here. And that was all fine and well, except that I had this issue where when, let's say a game stopped sending direct samples, well, the last value I had was stale. And I tried to fix that by resetting it in this place here, which turned out to not really make any sense. And I had this big fat comment about it. Anyway, I decided to get rid of that. In the end, what I should have done is actually, after consuming it, what I should have done really is made an optional around this. And if it's set, sample it, and after that like reset, or like just basically disable the value, so optional allows you to say, do I have a value or not? So I could have said, now there's no more value, so if ever no more samples are set, then I can just basically ignore it and just like use 0 or something. But instead I went a step further and decided to improve the quality of the samples by basically every time there's a write, rather than just remembering the last one, I just accumulate all of them. And so I have this new type called, here, let me just open it up, called average value. Really nothing special, but just allows you to keep adding values to it, and which increases a sum by the value you pass in, and it also has a counter, and then you can ask for the average value. So all I do is I keep adding values to it, and then when it's time to sample, I call this average and reset. So I get back the average value and it resets internally to 0, and I get this direct sample, which ends up being the average of all direct samples that have been sent since the last time. This actually improved the quality of the direct samples, so that's kind of nice. And I also ended up using this in the next change here for not just the direct samples, but even for my PSG audio samples. So there's a nice like kind of symmetry that ends up appearing in this code. So now for PSG audio samples, I basically every cycle sample what comes out of the PSG, and then when it's time to produce an output sample, I now do the same thing I did for direct, but for the PSG. So there's the average and reset. There's the average and reset for both. I left this in comments. I should probably just delete that. And in the end, yeah, basically we make an output sample out of that. So that's kind of nice. That also seemed to have improved the quality. And finally, if both tone and noise are disabled on a channel, yeah, still not 100% sure on this one. So this is me trying to like fix some final issues with the audio. Basically, I'm not even sure this is right, but like what I do here is by default I say I have my sample is 0, but yeah, so if the tone and on a specific channel, if tone and noise is enabled on that channel, I know what to do. I basically grab those values, I AND them, and then that's what I use. If tone is enabled, I use that. And if noise is enabled, I use the noise one. But what if neither one is enabled? What I was doing was I had a value of 0, and then this ends up becoming -1. And so I don't know if that's right. And I felt like when nothing is enabled, it should probably return the center value, which would be not -1, but 0. So I added this in. Not sure it makes much of a difference. It didn't seem to, so I might remove this, but I'm sort of working on trying to improve the quality of the sound. I actually have this work in progress commit here that I've sort of reverted, and I'm not sure yet what I want to do. Like it's basically a bunch of changes where if you had been watching last stream, I had tried to fix some like weird sounds that we were getting, like glitchy sounding things, by trying to detect whether my, let's say the tone generator should even produce or toggle its values based on the period that was set. And I'm not sure that's correct. And I keep rereading and rereading the docs. I've tried different things. Nothing quite sounds right. So I'll do like a little demo here. I'm not even sure if we can hear it, because honestly, I hear it best when when I put my earbuds on my laptop. I don't know how well I'm going to hear it here. Let's just give it a shot and we'll see. Like it doesn't sound horrible by any measure. It's really like minor things. So that's actually pretty good, right? So all that's good. Nothing to complain about there. Oh, and to continue testing digital audio, I actually asked on this Vectrex Facebook group that I'm part of if people knew of other games, ROMs, or anything where I could test digital audio, and I got a few, so I can actually share that here. I'm gonna play some of them. So there are actually 4 ROMs I have that have digital audio. So Spike is the one we just listened to now. There's one here that Malban put together, and it was a test for mixing digital audio with rendering that he did. So it's really, really simple, but it'll show that it works. So I'm not quite sure what he's saying. It's something, hello, tuck to come down here or something. And you can hear there's a kind of like a high-pitched buzzing in there. And I'm not quite sure what that is. And I think that's not I don't, either it's part of it or it's not right. I need to look into that. This one here is kind of interesting when it works. It seems to be a recording from a Vectrex commercial. No, these are downloaded, and some people actually shared the files with me. So I don't know if you can hear that. It says, "Forget the TV, get into Vectrex." I think it can be clearer. You know, this it sounds all right. So yeah, that's another one. But you know, we can sort of hear it. And then there's Moonlander. So this is another game. It's a homebrew game, and it has a countdown that's digitized: 4, 3, 2, 1. So that's the other one. And in this one, I can hear weird things like the dun dun dun. Then there's like a kind of a. Oh, now you won't hear it there because there's only 2 of them. But let me fast forward here. There. So it's like dun dun, and then you'll hear it a second time here. And that sound, I don't think it's right. When I tried this in a couple of other emulators that seem to have pretty good sound emulation, I don't hear that. So these are like the minor niggles, you know, minor things that are bothering me that I gotta address. It's getting hard to do so. Like I've been kind of messing around with, you know, because it's crazy. Like, you know, we're talking about, you know, changes to counters on a per cycle basis here. There's divisions, you know, we're dividing the clock by 16 and then clock by 16 again. And then, you know, there's weird, very, very minute timing details that just a small change in these things can completely alter the sound. But it's very difficult because the documentation that I have, which is basically this one here, it's okay, but it doesn't really go into so much detail. Like I've reread these things over and over. There's some questions I have, like I forgot why I have this extra divide by 16 here. I can't quite reason about it when I look at the code. When I read the docs. And if I remove it, well, the noise doesn't sound right at all. So there's all these kind of questions. So what I decided to do is, rather than just tweak and tweak and tweak and guess and all that, I'm going to work on, what I want to work on is I want to refactor a little bit the code in my PSG. There's some stuff in here that's been bothering me. And so I want to kind of simplify, and then I want to produce, like, I want to add some more debugging controls, some more graphs so that I can see exactly what signals are being produced by the separate components. So like I want to see, let's say, for each of the 3 channels, what is the noise generator doing? What is the tone generator doing? And what is the volume envelope doing? So these kinds of things I think will help me to sort of hone in on what's producing the weird signals. And I want to be able to toggle them on and off and all that. So, but to do that, I tried to do something like it last stream, and it was kind of annoying. And mainly the reason why it's annoying is that I haven't quite modeled the channels themselves. I'm kind of effectively keeping the values that control the channels in their bit flag format, and then I do a lot of, like, you know, bit manipulation and bit reads and stuff like that to figure out what we're supposed to do. So that's like a lot of the mess that you see in here of, like, you know, convert this index into a tone channel, which is a function that, like, does some shifting of this value that gives me back a bit mask. And honestly, like, it's kind of difficult to work with. So that's it. My plan is to change this. So that's what I'm going to do tonight. And, you know, we'll see where it gets me. If I get something that's more easy to debug, maybe it'll expose where I need to focus my efforts to just clean up these last few things related to sound. So yeah, that's my That's my plan. So actually, before I get started, I'm just gonna go get myself some water because I realize I don't have any, and talking a lot makes me thirsty. So I'll be right back. I'll just put some music on and just be right back. Okay. All right, that's better. Okay, so let me get started on this. I think for the most part, my goal will be to get rid of this this registers thing. So actually, before I get started, I'm gonna. Yeah, I wonder if I should even bother committing this thing. Yeah, I'll just say like, or I'll say remove period checks from generators, yeah, something like that. Good enough. Gets the right. I also realize I should reorder these. 0, 1. Yeah, the lows go before the highs. That's 0. 5. 6 is noise generator. And then technically should be mixer control. So see, mixer control is one I'm going to want to handle specifically. So I'm going to do here is I'm going to say case mixer control register mixer control. That was weird. Okay, there we go. Say break. Or yeah, it's okay. Just for now. Mixer control amplitude A, B, and C are currently not being see, anything that basically is not inside this table is just being handled by whatever's in registers here, and I want to get rid of that. So amplitude A, B, for now. Period high, so this should have been period low before highs. This is 10, 9, 11, 12. Envelope shape is 13. And then I have these last two. I'll spell them out. And so now I should have handled them all. So we'll just put a little insert false here. Or, yeah, whatever. And then let me replicate this. Down here. This is the right function. Noise generator. So here, mixer control, I do have an assertion, but whatever. And envelope period high. Okay, so we'll do these three. And it should be period low. Period shape. And then finally these here and the asserts. Okay. Now, what I'm thinking is we want something PSG channel. Here, let me write this in here and then I'll move it up. Now, a channel always has a tone generator, but I want to keep the tone generators out here, so I'm going to make a reference to it. So something like this. It might have a noise generator. It has an option for, I'm going to try to remember here. Right, it's got an amplitude thing. So what we're going to want to do is we're just going to want to also model the amplitude stuff here separately for each one. Yes. Get channel volume. Right, there's only one noise generator and only one envelope generator. So maybe something like exactly what I named my namespace here. Okay, so let's see here. It'll be fixed or envelope. we'll want the volume itself, the fixed volume itself, which was a uint32. Okay. Actually, yeah, not sure. I'm wondering if I should put a pointer here to the envelope generator. So a channel will have an amplitude control. So whether tone or noise is enabled, I think that's pretty much it. Okay. See here. Actually, I'll do this. Actually, all these should probably have my usual m underscore. In fact, I'll make these pointers themselves consts since they'll be initialized. m underscore. There we go. Okay. I don't know if I can actually initialize these correctly in the initialization array. We'll find out. I need a constructor. Let's see. So I need to pass it. Oh yes, and I need to initialize my amplitude control as well. And that guy wants the envelope generator as well, right? So let's do this. So PSG channel needs the tone. Oh yeah, the thing is I may not have a noise generator. Ugh. Oh no, that's okay. It's whether it's enabled or not that matters. Yeah, it's a little bit weird, but it's okay. It's a bit weird to be referencing like the same instances across the channels, but that's just the way it's been designed, so that's all right. So each one gets its own tone generator. You get the 0 with 1. Then it's noise generator, so m underscore noise generator. And then it's underscore envelope generator. Let's see if this compiles. All right, so it's getting confused because I called the other class amplitude control. I knew I'd get into trouble for that. Okay, for now, I think I'm gonna do this. Oh, cool, it actually compiles. I'll iterate a bit more before I make any major decisions here, but I will at least take this out of here. Next. To be honest, I'm also wondering if I should just make all of these public. Don't really see why I need to put accessors everywhere. I'm gonna try this just for now. If I do stick to this, I'll probably end up removing the m underscore. I just want to see how it feels to not bother. Thinking about fixed volume, mode, the value, and then writing stuff to the envelope generator. Okay, I'll do the same for here. So now the idea would be that when we get writes, let's say for amplitude A, B, and C, let's start with that. Maybe not the reads. Let's focus on the writes. So let's say I get a write to amplitude A. We'd want to get channels of 0 and dot amplitude control. And then here we have to decide what to do with the values that we're getting written to, that are being written. Okay, so we can say the mode is equal to amplitude control get mode of the register value, right? Yes. Yes, but we don't have the same type here. That's true. Do this. Call it amplitude mode. Okay, channels of 0, amplitude control, and let's write the fixed volume, which may or may not make much sense, but it's okay. or maybe I should say if it's set, if it's fixed volume. Let's read those values. I wonder if I should care. Maybe I shouldn't care. Oops. I think that's it for amplitude control. So now, of course, I'm going to have to do this for all of them. So what we'll do instead, we'll just do this. There we go. In fact, forget the index. We'll just plop that in there. And we grab our channel. So this will work for all three. We set the mode, we set the fixed volume. Great. And I think we will continue to write. That's the thing. We want to. These values do not change. Yeah, for some of these we want to kind of keep writing to the register, and because we're going to be returning it as is. So maybe I'll be explicit about that. I don't know. Okay, let's do it like this. So next is for the tone, no, for the mixer control, right? Yes, for the mixer control, which really is only about enabling or disabling the state. Channels 0. So let's say tone enabled. And this will be mixer control. So give me the value, which is the register. Wait, is that true? Yeah, it is. Okay, it's the value in that register, right? So this is the value we're going to store in there. But specifically for tone A. mixer control, tone A, like that. Tone B, and tone C, and then similarly, I think that's it for those. And I think that basically sets up now our channels with everything we need to know. We set up the mode, the fixed volume, and then the rest are just aliases to the pre-configured tone generators, noise, and an envelope generator. So now that I have all that, and let me just think here for a second, and then we still break for the read. Because I think for the read, I'm just going to leave it the way it is. Okay, great. This should compile. And it doesn't. Ah, yes. This becomes amplitude mode. But we will be redoing this. Initialization of channel is, oh yeah. So that builds. So now that comes the part where we simplify how we do the sampling and getting of volumes and all that. All of this code should be simplified, and so should the ability to disable and enable things. So let's see how that goes. Hey, what's up, Michael C? Things are going well. I'm just doing a little bit of rework, refactoring in my PSG code. How you doing? Cool, cool. Yeah, I decided to do some refactoring because I want to. Can't remember what I was doing the last time you were watching. So I've been working on audio. Probably the last time you watched, I was implementing digital sample support. So most things are working now. I think actually if I run right now, things should still work. I think I'm still in a working state. So I can demo a little bit for you if you want. I don't mind. So there you have audio with the digital samples working. And I was showing some other cute samples that actually have audio, like digital samples as well, like this one here. Not games per se, just like little demos people put together. So that's saying forget the TV, get into Vectrex. So yeah, things like that. So right now, like I still have a couple of minor issues with the audio, and what I want to do is I want to be able to add some more debug information, show graphs for each of the channels, and to do that, I right now, like the way I've been handling all this code is, using like bit masks to like extract the values out of the registers that have been written to. And that's all fine and well, except that it's kind of annoying to write and annoying to support for debug and stuff. So I've decided to change it up and actually model each, the channel with all its stuff that it supports, the amplitude control and tone and noise, everything per channel. And then when we write to those specific registers, what I've done now, this is really since the last half hour or less, is rather than just writing a value to a register here, that I go and I grab my channel, the correct channel, and set certain values in there. And so now I'm going to rewrite the code that does the sampling of each channel in terms of my classes that I wrote, because I think it's going to be a lot simpler to understand, and it's going to allow me to more easily like turn on and off things for debugging purposes, and to like write my code for showing debug graphs and stuff. So basically the Vectrex has 3 sound channels that it can mix. Each channel has a tone generator, they call it, which is basically a square wave generator. And it has a noise generator. Now the noise generator there's only one, but it can be assigned to none, 1 or 2 or 3 channels. And it has a envelope volume that it can share as well across the 3. And that's pretty much it, really. That's the whole Vectrex sound chip right there. So you can kind of see it, like if we go down here, it's basically made up of 3 tone generators, a noise generator, and an envelope generator. So those are the things that produce the curves, the waves, and while the envelope generator is used for modulating the amplitude. And then what I just added now is this higher level structure to store the information per channel. There are 3 of them, and what I'm doing in there is a channel is made up of whether or not tone and noise is enabled, and it has a tone generator and a noise generator. And in fact, I think about it, these could totally just be references. No need to do that. Let's see here. Now we'll make them const, and like this. There we go. So yeah, so now that I have it all modeled nicely, I can more easily implement the sampling logic. So let's do that. Yeah, exactly. The NES, the NES, which I've written an emulator for, had better sound options. And I mean, it's kind of obvious, right? You listen to the NES and you listen to the Vectrex. But yeah, when I had to model it, there was way more to do. It had like a couple of pulse waves, so more than just square. So pulse wave generators, a triangle wave generator, noise as well, a much more sophisticated envelope generator. It also had something for producing digital audio in the sound chip itself. Like it actually had support for playback of samples, which the Vectrex doesn't have. So to do that for the Vectrex, you kind of disable the PSG and you write directly at your, from the CPU at a given whatever sampling rate you want, and you write kind of directly to the speaker. That's right, the PCM, that's it. I actually didn't model the PCM in my NES emulator, so like games like Blades of Steel that play samples through it, they don't play that for me. But anyway, so for the Vectrex, it was a bit simpler to do the digital sample support just because it's much more straightforward. So that's pretty good. PCM was on my to-do list for the NES emulator. The to-do list that grows forever and never gets never changes. All right, so let's see how this will go. I'm gonna try to, how do I want to do this? I guess I could write a function on the channel to just called sample. That would make a lot of sense. I have a few projects that I need to model an audio chip for, just not sure how to set up an SDL audio system though. Yeah, it's actually really not that hard. If you're interested in looking at my code, you can just go on GitHub and you can take a look at the SDL audio driver. So it's basically this code here. And you'll see it's pretty straightforward. Most of it is just setting up SDL so that it so that you can tell it which which format you want to send it. And then after that, there's a callback that you register with it, and it's going to call you back, and you need to kind of feed it samples at whatever thing you asked for. So, and I think if you want, you could just use what I wrote, modify it as you will. But what's nice about it is that it even does kind of like, it detects when if you're not able to feed it fast enough, it kind of pauses and waits for you to add more, and then and then it resumes and stuff. So it's pretty good. It does the trick. So if you're looking for some inspiration or just want to grab the code, you can. Yeah, no problem. So let's see here. For volume, I'm going to do, I guess I need to do a get volume on the amplitude control. Let's do that. I guess this can be const as well. For now, I'll just say return 0. This here will say if the mode is fixed, and in fact, it's not quite fixed volume that I want. That's it. I have this code here. Yeah, that's not quite right. Okay, so it's more like this. Just kind of copy the same code I wrote here. Otherwise it's envelope, in which case we will use the envelope generator to get the volume. You know what, I'll do the switch. I like seeing the explicit modes being listed, just like I did before. With value, yeah. And then I'll do this. Whoops. Okay, back to sampling. So sampling is, we'll grab the volume and we'll check if it's 0 and we'll return. I hate when my autocomplete doesn't work. Oh, that's cool. Master system. So 3 square waves and a noise. So that sounds really a lot like the Vectrex. And no envelope generator in there. Okay. Oh, that's interesting. So it'll be similar to what I've been working on here. Moo balls, yeah. How's it going, Moo balls? Yeah, sometimes closing or reopen, but actually, you know what? When it doesn't work, in like most of the time, it's because the code's not compiling, and so their you know inline whatever compiler is stopped working, and so yeah, and sure enough, I do have a problem right now. Oh yes, I can't do this. That's true. And this, now that these are references, volume and pitch registers, yeah, that's pretty much the same here. Yeah, so basically when you say pitch, basically you're talking about being able to set the frequency. For the Vectrex, you set the period values for the square waves, and well, for the 3 generators you set periods. So I assume it's different, same for you, because that is what affects the pitch. All right, so this compiles again. Yeah, so Mooball, sometimes when it doesn't work, you know, first thing is I suspect is it's not compiling, and then if it is compiling and it's still not working, you're saying closing Visual Studio and opening it fixes it. That's true. Sometimes it does. When that doesn't work, I actually go in and there's a file you can just delete. You probably know this, but there's a build in the .vs folder in v15 here. You've got these vc.db and opendb files. Like all of these are the IntelliSense database files. I don't exactly know what all of them are. I know there's like, I think OpenDB is a new format. Anyway, whatever. You just delete all of these and reopen the project. Yeah, so Michael C, you're saying it's just a reset value for a decrementing counter. For the Vectrex, they call it the period, and in the case of the square wave, it's actually the time for the square to go, for the signal to go both up and down. So I actually divided by 2 to get the duty cycle, right? The duty time. So I have to divide the period by 2, and it's at that, then my counter goes down for that rate, and that's how I toggle between up and down values. So like between 0 and 1. That's at least in my case. So I guess it depends on all the hardware. I don't know what it is exactly for the master system, but that's what works for Vectrex. Okay, so now, oh yes, I was trying to get the volume. There's my IntelliSense volume. And then we do something like this. See, this code is going to look very similar. You know what I'll just do is I'll just copy all of this, and then we'll adapt. There we go. See, this code is a lot simpler. It looks the same, but there's a lot of simplicity. Like here I have to pass in a whole bunch of parameters, which amplitude register, the mixer control, the index, and then I have to do this conversion of index and stuff. All of this is kind of messy. Now it's all pretty straightforward. So this code's going to change quite a bit. It's going to just look like this now. All of this is going to disappear. And then we're going to do, I don't need this, I don't need this, I don't need any of this. And we're just going to go sample plus equals channels of I dot sample. There we go. Now, if I didn't break anything, if everything's programmed correctly, it should sound the same. So let's see if it's working. That's a good sign. I like how you can like kick multiple times. By the way, I mentioned this on my stream last time, but there's actually a bug in this game, in my emulator I mean, where you can't see the platforms that you're supposed to fall, that you can fall down from, like here. There are lines that are not, like these two lines should not have been rendered. So yeah, there's a bug in my line drawing code, and it's not the first time I've seen this. This happened to me. It was specifically this game, Spike. There's something weird about how it draws lines. Oh, hey, thanks for the follow, NotBren24. I think with this follow, if I'm not mistaken, yeah, that puts me at 256 followers, which means I've broken the unsigned char value. So that's fun. So yeah, so basically there's something weird about how it draws, and I have like an optimization to try to detect when a line is continued, and that code seems to be not working only in this game, really. It's the only game where I've really noticed this. So anyways, I need to fix that, because otherwise this game is completely unplayable. So, okay. This is cool. So let me delete all this code. This point. Get rid of this all together and just move this into sample. I have way too much code in this header file, but my plan is to do what I've done in many places and turn the PSG into a use Pimple to just kind of hide all the stuff in the CPP file, because yeah, not a fan of this, but it's okay. Not a rush. So actually, having done this, I'm going to, I see that I'm not really accessing these things externally too much. So I think I will do the private thing here and do some setters and stuff like that. So that'll change this code here to be like set uppercase that. Ah, yes, getting the amplitude control here. Okay. What's wrong with this? Oh, because I use the same function name. That's always annoying. No, that's not really the problem. Okay, m underscore amplitude. Oh yeah, unknown over. Oh right, yeah, it is the problem because it's a function. It's kind of hilarious. Thought I could do this. Same problem. Okay. So don't need this. Oh yes, I should fix this. Okay, forget this for a second. So I still have code that's using some of my functions here. Yes, is producing sound. Okay, so this we could do better. In fact, I even removed these, so all of this won't work. So what am I doing? Oh yes, we just want to see if the tone is enabled. Don't need that. I can do if autoref channel in m channels if channel dot tone enabled or channel dot noise enabled return true. Boom. So nice. So I realize actually that this can also be a range-based for loop. Like that. The code just becomes way clearer when you model things correctly. Eventually I want to have a go at the PS1's SPU. That's the sound chip, right, on the PS1? The sound processing unit. That sounds cool. Well, yeah, the PS1 definitely had a nice, you know, it could play like a CD quality audio, right? If I'm not mistaken. So are these just projects where, not just, I mean, what I mean to say is, are these not emulators that you're writing? Like you're working on emulating specifically the sound chip so that you can play samples or play like audio files for these systems? Or is it part of an emulator project that you're working on? Okay, it is for an emulator. Okay. That's cool, man. That's really cool. Okay, so I wanted to rename this. So I like trying this rename tool in Visual Studio to see how good it is. I want to say register. I guess that's all right. Now let's see what it picks out. Okay, that's all good. See, it's really well done. Basically, if it's... Oh, hey, thanks for the follow. Enter Ramano, if I've said that right. It's really cool, this thing. Like, basically, there's an option that says, just go ahead and do the rename if there's no questions, like if you're not confused by anything. But otherwise, it opens this dialog and it says, just make sure that I'm right, you know? And you can go click and it shows you the instances in here. There's unconfirmed references. So this is what it wants to know about. Like this, what's the difference here? PSG, mixer control 7. Yeah, so see it's saying, I don't know why it's outlining anonymous namespace mixer control here. Because that's what's up here. So I don't know what that is. But for the PSG, it's saying, I see mixer control in there, but that's not the same type, so you probably don't want to touch that. But if in case you do, let me know. And then, of course, those go together with these here, so I don't really want them, and those are unchecked. And then finally, it's saying you probably want to rename the namespace text here, which is true. So it's pretty smart. And that's part of a comment, so I'm pretty impressed with this rename tool. And what's cool too here, it shows you a preview of what it would look like once renamed. It's true, you have to be careful. But so far so good, you know? I haven't been really bitten by it too much. I see Mooballs, you're another Visual Studio user. That's pretty cool. I like VS, and I think they've done a lot of good work in 2017. Okay, so now I just wanted to see. Yeah, that's going to be no big deal. So you see, you can do skip preview changes if references are all confirmed. You know, if you turn this off, you have to always look. And, you know, I'll just be a rebel and trust it. But yeah, here looks pretty good. That's the header file. Looks good to me. And now I can rip out this class from here. So amplitude control on its own, PSG. This is a lot easier to read now. Okay, so this should all be good. I think I'm going to commit this. Okay. So I'll say something like model PSG channels into classes, refactor code, sampling code, in terms of something like that, whatever. Don't you love how it doesn't know what refactor is? Anyway, commit. So it's already 11. I'm gonna see if I can quickly do what I wanted to do, which is at least expose the enabling, disabling, kind of a master control here for the different channels. I don't know what to call it, because it has a concept of whether tone is enabled or not, and it's used internally, so I can't do this from the outside. What would be the cleanest way? Okay, I'll try, whoops. I will try to keep it externalized just to see if I can make some sense of this. Oh no, I can't do that. Maybe something like this. Let me just try something. It's really for debugging. Oh wait, I could do this. I could do this. Yes. Okay, this is what I'm thinking. Basically, when I sample, yeah. In here, I mean, it makes my sampling code a little bit less clean, but I do like keeping the code external. So let's see. It would be something like, start with this. I guess I'll have to go back to my old for loop here. So we do this, channel debug options of I. And what I'm thinking is something like, so I don't love it, but it does mean that oh yeah, because we're const. Yeah, that sucks. Yeah, that's kind of sucky. So maybe I'll just go back to just putting it directly in the channel. I hate negative logic. Something like this. Okay, so we can bring this back. Then in my frame update, so checkbox, and here we're going to say tone. Okay, I need to say that which channel it is, so I'll say, okay, I'll go tone A. Actually, I don't know it's A. So actually, we'll use an index. So we'll say tone %d like this. I'll use my formatted string thing. And then for the bool, we want to give it channels of I. Here, I'll just that, and in a similar vein, we'll do the same for noise. That should be it. Let's see, PSG. So I got tone, noise. Let's You know what? I'll pick a game that has more sound that plays all the time. So let's go here, ROMs, Scramble. See that sound? I can tell now that the tone 0 here is making this awful sound here, right? So that's going to help. And now what we're going to do is we're going to want to graph for each of the channels. What is exactly the graph of the tone 0, of noise 0, and also of envelope, which hey Raptor. Yeah. Oh no, it is very cool. It is really cool to hear. It totally is a nostalgia a nostalgia feeling, you know? Yeah, I'll just do something cute here. I'll do a little auto index to channel name. That is true. Okay. Or actually maybe just do like, I don't even know, need to really a function, do I? Just do like, I do want a string. Yeah, I'll just leave that alone. Okay, so now it should look like, it should say tone A, noise A, and all that. Perfect. Yeah, I'm realizing that I'm doing this pattern a lot, so I'm just wondering if I should just make a small something like this. Something like that. Maybe not increment. So I do this, I have a clear, I'll have a yeah, ImGui is great. Thanks for hanging out, Raptor. Yeah, this thing, if you add the last value, it ends up clearing. That's kind of sucky. Maybe what I'll do is I'll do it like this. Yeah, that's better. Okay, now as a test, what we want is we want one of these for each of the channels. Let's try this. Tone history. Yes, plot data, float values, and 10,000 seems to be the number of the day. And what we want to do is something like this. data.data. And then the size. Is it not size? Oh yeah, it's data.size. All right, so let's see how this looks. Oh yeah, probably a good idea to actually add some values to these. What? What's it saying? Oh, because it's got the same name. Histories. All right. Let's add a value. And it's going to be channel dot, we're looking at tone here, right? Do I even have a way to get to the tone? I don't, because I never exposed it. Right. So we'll just expose it then. Tone generator value. So now this should work. Or not. What's the problem? Conversion from write to float. That's true. Is the reason why I'm saying it should be float? I've got the 15 here. Oh yeah, because it wants floats, doesn't it? Yes. What's I doing here? Yeah, I'm casting the float. There we go. Yeah, no longer needed this. This is now values. This is not envelope history though. This is values, that size. Okay, let's see now. Oh, actually, it isn't in the 15 range. Now it is going to be 1 here. It's for this specific plot. 15 is for the envelope volume stuff, so. So it's working. Yeah, that's a good question. I hope not. Let me see. So decal type auto is supposed to do the right thing, but you're right. It's not completely clear. I just didn't feel like spelling out, but you're right. Is this going to be a ref? That's what I want it to be. Yeah, this might be by value, isn't it? How do you... Can you do this? No. Let me see here. I don't use decal type auto a lot. My gut was to, like, you know, because basically what I want is this, you know, and I hate spelling out, copying things twice. So I was like, oh, you know, I'll give it a name and you know, like basically a type def. And I was like, maybe I can use decal type auto. So it says here if it's an L value, it's tref. Yeah, so yeah, it looks like I can't do that. Decal type auto is kind of a strange beast, you know? Let me see if this, I should put it here. Yeah, because here it looks like I'm getting, oh no, I gotta put ref here, right? Initial value of reference to non-const must be an L value. Right. Initial value of reference to non-const. So this is returning non-const, and that's because I didn't put const here. Presumably. Maybe not. Okay. So this is not a real warning. But let's see. So that seems to compile, and so that means that I ended up with, yeah, I don't trust this. I think the best way for us to figure this out is the little trick that I use whenever I'm like, what is the type of this thing? You know, you do something like this, say like show type, and you don't give it a definition, and then you do something like show type with the template parameter being the, of course I have to do decal type, so then I don't know if that's going to be valid, but sorry, it's not that way. It's like this. This. Yeah, I don't know if I could trust the decal type either. I do not know how it works. Return reference. I think that if I have to hunt this long, it's probably not the right feature to use. But I'd like to understand it, you know? Oh, it's not about decal type auto. Too complicated. I think that what I'm reading here is that, so the equivalent in C++11 is here, where you can use the trailing return type. In C++14, you can use decal type auto, but I can see here they're using forward of the T here. This is because these are forwarding functions, but it's not clear to me what it will do with an L value. I might need to call stood forward on it. Yeah, I'm not sure. So let's just go with this. I'll look into decal type auto a bit more and try to understand it. I'll reread the section in the Scott Meyers modern, effective modern C++. I think it'll help clarify that stuff again. Yeah, so this works. I think maybe 10,000 might be a bit much. I'm going to try making it smaller, seeing if we can actually tell what's going on with the values. Okay, so now it definitely writes a lot faster. Okay, that's pretty good. So now it should be fairly trivial to add noise in there. Yeah, that's what they're saying. Yeah, I know, the parenthesized thing, that was a big point of contention for a lot of people when it first was being when C++ 14 first came out. A lot of people were complaining about that extremely confusing feature. But I mean, it kind of makes sense, right? Because like, anyway, whatever. I don't feel like getting into it. Something about the parenthesize as an expression, and why is it again that it turns that into an L value? I don't even remember. It's been too long. One of the things I pulled up was all about that, right? This thing here. It says it. That is not an unparenthesized ID expression or class member access. So we go to the second bullet. If it is not an X value, so we go to the third, it is an L value, so the type is tref. So here it says M is already an L value, and parentheses of M is also an L value. The point is that the parentheses alter how decal type make it deduce the type. Without the double parentheses, you just get the type of M. With double parentheses, you either get tref or tref, depending on whether M is an L value or R value. And in your example, it's an L value. What I don't get is why. In essence, it allows two different queries to be made with decal type, asking whether what is the type of this variable, or what is the type and value category of this expression. The extra parentheses are the syntax for the latter. So it's not like it's not like it makes sense. You know, like, oh yeah, because it's parenthesized. Because actually, to me, parentheses just means if you turn it into an expression, I would almost expect it not to give you references. But it's more like, well, you know, there was no way to get at the value category of the expression. Oh no, maybe it does make sense. What is the type and value category of this expression? So yeah, I guess that makes sense because you parenthesize it, it turns it into an expression. Yeah, maybe it makes sense. I don't know. Anyway, it's like a way to enable you to get in. So I guess I could go back to decal type, and if I parenthesize my data member, it might work. I'd have to do some tests. I mean, we could actually step in and see if it copies it, right? We'll see if it calls a constructor and all that. That would be one way. Noise will probably not be the most interesting one to look at, but let's see. Yeah, it is C++. That's true. Not really helping me very much. I was hoping I'd see more. Maybe if I reduce this even further. Let me just see if a pattern or something becomes evident. That's fast. Yeah, definitely a bug in the tone generator. This is not really showing it to me, but we'll. I'm gonna stop here, and we'll pick this up in a couple days. But I think we're just being able at least to hone in, and I'll think a little bit more about what we can do to understand this. I'll read some more on the tone generator and see if we can figure this out. So yeah, thanks for watching, guys, and yeah, I'll be back in a couple days. So Thursday night, usual time, 9 p.m. Eastern. So yeah, thanks a lot for watching.